Thank you very much for the introduction. I'm Davide Scaramuzza, and I'm a professor at the University of Zurich, where we work on vision-based drones. So drones that can fly all by themselves, only using onboard cameras, not GPS. Today I want to talk about perception, because without perceptions, no robot can actually be completely autonomous. And let me start trying to give you a quite clear example of why perception can really change not just autonomy, but make robots truly useful. What is this picture showing? So who of you has a vacuum cleaning robot at home? Raise your hand if you have. So 7 people. Not too bad. This picture, it's a long exposure picture that shows a Roomba vacuum cleaning robot cleaning a 20 square meter room. You know how many minutes it took until 2018? 20 minutes. The year later, Roomba released a new vacuum cleaning robot that now could do the cleaning of the same room in less than 5 minutes. What changed? Well, you can see what changed. The robot is much smarter now. It's actually traveling smarter rectilinear trajectories. What made it possible? Only one sensor, a camera. So the robot on the left was completely blind, and it had no intelligence. From 2018 onwards, they added a camera that made the robot able to see. And by being able to see, the robot became more productive. Is it still more productive than human? How long does it take you to vacuum clean the same bedroom? Probably takes you 1 minute. So we are still far from human-level performance, even with vacuum cleaning robots. Let me show you another application where perception made a change. You're all very familiar with Atlas from Boston Dynamics, doing these kind of things. What made this leap forward to Atlas that was impossible until only a few years ago? Perception. This is the behind the scenes. Atlas has multiple cameras that build a three-dimensional map of the environment so that the robot can identify obstacles and predict where it should land and put its feet. Where else has perception made a change? To Mars. What you see here is the NASA Mars Ingenuity helicopter that since 2020 until 2024 was actually flying completely autonomously and performed more than 70 autonomous flights. And it was possible only thanks to an onboard camera and a computer. By the way, for those of you who don't know, this is the first truly autonomous robot on another planet. What about the rovers? They were not fully autonomous. They were still controlled from Earth with a communication delay of up to 20 minutes.
Golden Leader Pass holders can go to room 14 inside the Leaders Lounge on the 2nd floor for their buffet lunch. All other pass
I wait for the speaker to lunch.
At the ground floor cafe or the first floor cafeteria. Bon appetit!
So perception, also called computer vision, is making mobile robots autonomous. But the reality is that humans are still preferred in most applications. Look around. Not around here, of course, today, but around you in everyday life. How many robots do you see? Almost none. Why? The reason is because current robots are far from human performance in agility, versatility, and robustness. What is agility? Agility means that they should be faster than humans performing tasks. Versatility means they should be able not just to do a single task, but multiple tasks. And robustness is very important. It means they should never fail. We fail, but not so often, to be honest with you. Just to give you a comparison metric, you know how many kilometers you need to drive on average before you have an accident? 100 million kilometers. Most of us will never have an accident in our entire life, hopefully. But this is the reality. Humans are truly, truly robust, and machines are not yet at human level. Now, in my lab, we have been working for many years on autonomous drones. Our dream is to develop an autopilot that can fly drones better than humans. If we manage to do so, we can extend these results to any other robot, because flying drones are truly, truly difficult to navigate, because they fly in 3 dimensions. They are not constrained on the ground. Drones are so difficult to operate because without seeing a single image, they actually cannot even fly. Now, what you see in this video is not an autonomous drone. It's a drone operated by a human pilot. And human pilots take years to achieve the skills that you see in this video. But now let me answer probably a question you're answering. You're questioning yourself. Why do we bother about making flying drones so agile? Who cares? We want to have agile drones because we want to increase the productivity of drones. Why? Because drones can only fly for 20, 30 minutes. There is not much you can do in 20, 30 minutes. But if you can fly a drone faster, it can fly longer distances. What you see in this plot is the range in kilometers that, for example, the most sold drone in the market, which is the DJI Mavic drone, flies according to a certain speed. If you can fly at the optimal speed of 6 meters per second, which is about 20 kilometers per hour, then the drone will reach the longer distances. So it will become more and more useful. Where are current commercial drone companies? So if you take the 3 best commercial drone companies, DJI, Flyability, and Skydio, they are not truly flying at the optimal speed. They are very slow. So they are not really taking advantage of their potential. Why? Because flying fast raises a lot of challenges in perception. For example, motion blur, and also aerodynamic effects. Where are drone pilots instead? Drone pilots are on the opposite side. They are even too fast. Why do we care about making autonomous drones agile? Because by being agile, they will be able to fly longer distances and therefore be useful in applications that go from search and rescue, inspection, forest monitoring and wildfire prevention, passenger flight, and even space. But first of all, you need an agile drone. So some years ago, we started a collaboration with drone racing pilots. And thanks to their collaboration, we built a truly agile drone. The drone you see here is about 20 centimeters in diameter, and it can accelerate from 0 to 100 kilometers per hour in less than a second. It's much faster than a Formula One that takes 2.6 seconds. Then we have a computer on board, which is a very powerful smartphone processor. And then we have cameras to see. Now, thanks to machine learning, over the past years, we demonstrated unprecedented agility. Here you see our drone that is doing agile maneuvers, like acrobatic maneuvers, all by itself. No GPS, no human control. It's just using a single camera, an inertial sensor, and an onboard computer. All the images are processed at 50 Hertz on board. Why did we tackle this application? Who cares about drones making agile maneuvers? For the same reason why Boston Dynamics does parkour. Not because it's useful, but it's to push the limits of research in the hope that these things will benefit other fields. Thanks to machine learning, we were also able to fly the same drone in very difficult environments. For example, in unknown environments like forests. Here you see our drone flying at 40 kilometers per hour. Even outperforming commercial drones like Skydio, which instead bump because they don't see very well at high speed. But when you start using AI, you need a lot of data. Where do you get all the data to train these control and perception algorithms? You cannot get this data by flying drones in the wild. Why? First of all, because it's illegal. And second of all, because you will need probably decades to collect enough data. So what's the solution? Simulation. In simulation, you can simulate an unlimited amount of data. In only one night, we can simulate 100 drones flying hundreds of forests. And that's how we taught our drone how to fly in a forest better than humans. Another advantage of simulation is that it's cheap, it's safe, and it's very, very fast. You don't need any data collection in the real world. OK, great. Now, thanks to AI, combined with proper perception algorithms, we can fly drones in a way that seems very similar to the way humans are flying drones. But how far are we from human pilots? How would you measure whether you are better or not than human pilots? Well, human pilots actually measure their skills in a sport, like Formula One drivers do. It's drone racing. So 7 years ago, we started a collaboration with Marvin, the 3-time Swiss drone racing champion. This video, we recorded it when he was 15. He started racing at the age of 12. Human pilots wear goggles, and then there is a camera on board the drone that transfers the images in real time to the goggles with a minimal latency of 10 milliseconds. In these sports, you require very fast decision making, quick reaction times. There is no time to think. You have to be very, very reactive. You have to follow your instinct. And they train for years to get this agility, and they always crash eventually. Like when you surf, you will eventually always crash. So we have been working on drone racing for 7 years because we thought that by working on drone racing, we would push the limits on autonomous vision-based flight. After 7 years of work, in summer 2022, we invited not just Marvin, who was the Swiss champion, but we invited the world champions of drone racing. Alex Vanover, who is the world champion of the Drone Racing League, and Thomas Bidmatta, who is the world champion from the MultiGP International League. And we made them compete against Swift, our AI drone. Very important, the human and the AI drones were identical. The human and the AI drones were built according to the specification of the world champions. The mass was the same, the field of view was the same camera. The only difference was one was autonomous, the other one was operated by a human. By the way, what I'm going to show you is the result of 7 years of work. We failed plenty of times. We crashed our drones thousands of times, and we repaired them most of the times. We organized a race, which was a public event witnessed by thousands of people. The AI drone named Swift is in blue, and the world champion best was actually Alex Vanover, which is the one in red. Enjoy the race. The AI drone won, otherwise I wouldn't be here telling you the story, of course. Actually, we let the human pilots practice the racing track like in normal competitions for more than a week, day and night, as long as they wanted. We recorded thousands of trajectories that are all open source for people and researchers to actually test their algorithms. Our AI drone won the competition with a lead time of 0.5 seconds, which is a lot, because typically in human competitions, the difference between first and second is 0.1 seconds. So it was a significant margin. Additionally, the AI drone won 15 out of 25 races, so the majority of the races. The results were published in Nature, and it was released also open source. But when people see these videos, they think, hey, it's over. It's done. No, we have to be careful. I have to be cautious as a researcher. When you see videos from researchers, they were done in controlled environments. The illumination was controlled. The aerodynamic effects were controlled. Because the reality is that the real world is very, very difficult. We do not match human pilot performance in the real world in any setting, in any lighting conditions. Because robustness and versatility are the true challenges. Let me show you some spectacular crashes. As I said, we destroyed the drones in 7 years, thousands of times. But we are not the only ones to fail. And you know, without failure, there is no success. So that's what we learned. Was this research useful? By the way, what did we learn? Yes, we have had 3 spin-offs from our lab. The first one is Swind, which is building a world without crop losses. The idea is to build drones that are very agile, that can help to cut losses in crops, by flying drones faster than they were before, using onboard perception and computation, and also AI, of course. They fly also without GPS, so they can also fly under the tree canopy. We are focusing at the moment on crop spraying and also perimeter, forest perimeter monitoring. And next comes wildfire prevention. Another spin-off is PhotoKite, a tethered drone for first response. They have a booth over there. It was the first drone to have a tether attached to the battery of the firefighter truck, which allows them to actually do situation awareness. So you can use the drone as an eye in the sky to monitor, the extent of the wildfire and so on. Another spin-off, Zurich was acquired by Facebook. And they worked on the development on the Meta Quest, which sold more than 25 million units worldwide. In fact, the algorithms that we developed for the drones to do the three-dimension mapping and or estimation the motion of the camera of the drone are the same algorithms that are used by virtual reality headsets. And with this, I would like to thank you for your attention. Thank you. There is maybe some time for questions.
So thank you very much for the amazing presentation and excellent research work. My question is related to the real-time applications and what kind of platform did you use to meet the time constraints with a very limited time window?
Yeah. So all the algorithms were running on board the drone on a Jetson TX2 computer. The images were being processed at 50 hertz. This is actually more than enough. Consider that human pilots are actually quite slow. Human pilots have a reaction time of a quarter of a second. So our algorithms are actually 10 times faster than that, if you want. But the reason why humans are still unmatchable by machines in the real world is because humans can make better decisions in complex situations. Now, if you ask me the question, can real-time limit at the moment the autonomy of robots in general? Yes, indeed. We realize that nowadays, in the face of large language models and large visual models, which is very, very important, you need much more computing power. So we are moving away from onboard computation and rather to off-board computation, as long as it's available, so to the clouds, so you can run more sophisticated and powerful algorithms. As long as you are below the 250 milliseconds latency, you are going to be better than humans anyway.
Very, very impressive work. Are you familiar with Genius New York?
No.
It's largest drone startup competition in the world. Go check out Genius New York.
Okay,
and get $1 million.
Thank you. Any other question? Okay, thank you.